everybody! Today we're going to talk about some Lewis structures. I'm going to do everything from basic Lewis structures to pretty difficult ones. So hopefully you can get some help with whatever you're doing. So my first example is F2. And the first thing I like to do is go to the periodic table and find fluorine. And I see it's in the 7th row, so I know it has 7 valence electrons. But I have 2 fluorines, so I have 7 electrons times 2, and that equals 14 electrons. Perfect. So now the first step you need to do is pick a central atom. So my central atom in this case is going to be fluorine, of course. And then you need to make a single bond to the outer atoms. And the only outer atom in this case is fluorine again. So we'll make a little single bond there. Now a single bond counts for 2 electrons because there's 2 electrons within this single bond. So I have 14 electrons and I've used 2. So I have 12 left. Now your next job is to fill the outer octets of each electron, or of each atom, sorry. So fluorine, I'm going to add 2, 4, 6, 8, 10, 12. So I use 12 more electrons and I'm down to 0, so that's perfect. Now as you can see on my structure here, each fluorine has 8 electrons associated with it. So this fluorine has its 6 pairs, plus it's taking these 2 electrons as well. And then this fluorine has its own 6 pairs, and it's also using these 2 electrons. So each fluorine is good with its filled octet, is what we call it. So let's pick a harder example. Let's do methane, which is CH4. Alright, we're going to see the amount of electrons we need. So carbon over here is in group number 4, so we know it has 4 electrons. And hydrogen is in group number 1, so it has 1 valence electron. So I can come back here and I know carbon has 4 valence and hydrogen has 1 valence, but there's 4 hydrogens. So that gives us 8 electrons in the outer shells. Alright, so I start with my carbon, and because I'm going to choose the first atom as the central atom, and then I'm going to make bonds to the outer atoms. Alright, now I'm going to count my bonds. Each bond is 2. So 2, 4, 6, 8. Perfect, we've used all the electrons. Now, the special thing about hydrogen is that hydrogen's maximum shell can only hold 2 electrons. So it will only make 1 bond. It'll never have electrons on its outer shell. But that's your example for methane. And it looks like that. Alright, next example. PF5, so phosphorus and 5 fluorines. I'm going to go back to my periodic table. Now I see phosphorus is in row 5, so it has 5 valence electrons, and fluorine is in row 7, and it has 7 valence electrons. Alright, so phosphorus had 5, and fluorine has 7, and there was 5 fluorines in this example. And that's going to give us 40 valence electrons. Alright, now in this case, again, our central atom is the first atom, which is phosphorus, so we're going to put it in the middle of the board. Oops. Alright, and now we're going to make single bonds to our outer atoms, and I have 5 fluorines, so I'm going to place 5 fluorines around the phosphorus. Alright, now I've used 5 single bonds, and each bond counts 2 electrons, which means I have used 10 electrons. So I'm going to subtract 10 from my 40, and I have 30 left to deal with. Now I'm going to start filling my outer octets. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Perfect. And we've used all of our electrons. So that is what your Lewis structure for PF5 looks like. Now, as you've noticed, the central atom here is making 5 bonds, and I've told you before that that's unusual. An atom should be making 4 bonds. It should have an octet. See, this fluorine has an octet going on here. But this phosphorus has 5 bonds, which means it has a dectet, I guess you would say. But if you go to your periodic table and look, phosphorus is in the second row. And whenever you have an element in the as the central atom that is in the second or third row, it can have more than a filled octet. But if you have an atom that is in this first row, it cannot have more than 4 bonds. So keep that in mind. If you have a carbon that has more than 4 bonds, you've done something wrong and you need to go back and look at it again. So just keep that in mind. For my next example, I'm going to do BrF5. Alright, that's bromine. So we're going to go back to our periodic table. And I have bromine in the 7th column, so it has 7 electrons. And again, fluorine is in the 7th column, so it has 7 valence electrons. And we're going to put Br as our central atom, because there's only one of him, and he's in the front. And we're going to surround it by the 5 fluorine atoms. Sorry, I forgot to add up our valence electrons here. So we're going to go bromine has 7 plus fluorine has 7, but there's 5 fluorines. So that gives us 42 electrons. Alright, so I'm going to make single bonds to our outer atoms. And each of those bonds is 2, so that uses 2 electrons. So we have counted for 10. So I'm left with 32. And I'm going to start filling the outer octets of the outer atoms. 6, 12, 18, 24, 30. Alright, I have 2 valence electrons that I need to work with left. But my outer octets are filled. So what you need to do is now put whatever is left on the central atom. And he gets 2 electrons. Alright, so now bromine here is actually having 6 regions associated with it. 5 bonds, and then your lone pair of electrons. So there is your diagram. I'll just redraw it over here for you. That's your Lewis structure for BF5. Alright, perfect. Let's do another one. Xenon with 2 fluorines attached to it. Back to the periodic table. We find xenon and it's in column 8. So it has 8 valence electrons in an outer shell. So it's very rare for xenon to actually bond because it has a full outer shell. And we also have 2 fluorines with 7 electrons in the outer shell each. So when we add that up, xenon has 8 plus 2 times 7 electrons in each fluorine. And that's 22 electrons. Alright, so let's choose xenon as our central atom and make bonds to the outer atom. So I have 2 fluorines. 2 bonds right there like that. And that makes 4 electrons. So I have 18 left. Let's fill the outer octets of fluorine. 2, 4, 6, 8, 10, 12. Alright, I have 6 electrons left to deal with, and they're all going to go on the central atom. Alright, so I've used the other 6 electrons, and we've used them all. Perfect. So in this case, we can see that xenon has 1, 2, 3, 4, 5 regions associated with it. And that's okay because it's not in the first row of the periodic table. It's over here in this row, so it can make more than 4 bonds. Last but not least, we're going to have a little bit harder of an example because it includes formal charge. Now, if you don't know what formal charge is, that's okay. Just ignore this and move on to the next video. So, SO3. Like always, we're going to go back and look at the periodic table for our valence electrons. So sulfur's in row 16, so it has 6 valence electrons, and O is also in row 16, it has 6 valence electrons. So I have sulfur with 6 plus 3 oxygens with 6 electrons each. And that's going to give me 24 electrons. Alright, we're going to pick sulfur as our central atom as always. And we're going to make single bonds to the outer oxygens. Alright, now we've used 2, 4, 6 electrons by making those bonds. So we have 18 electrons left to deal with. As always, we're going to go and put them on our outer shell. Alright, so I've used all of my other electrons. 6 valence electrons on each oxygen is 18. So I've used them all. Now, this is a correct Lewis structure, but there is a more correct one, and I'll show you why. Again, if you don't know formal charges, just ignore this. But formal charge is equal to the number of electrons, valence electrons that the atom has, minus lone electrons minus bonds. So we're going to do the formal charge for sulfur in this case. And if we go back to our periodic table, sulfur has 6 valence electrons. So I have 6, and we're going to subtract the lone electrons on sulfur, and it has 0 lone electrons, and then we're going to subtract the number of bonds it makes. So 1, 2, 3 bonds. And we're left with 3, which means that sulfur has a plus 3 formal charge. Now let's do the formal charge for oxygen. So oxygen has 6 valence electrons, and in our case, has 6 lone pair, or 6 electrons on the outer shell, and it is making 1 bond. So we have -1 as a formal charge on our oxygens. Now, elements and compounds don't like to have formal charge. It makes them less stable. So what we're going to do is we're going to reduce that formal charge. And we are going to reduce it by making extra bonds. Now, as you can see, sulfur, in this case, is only making 3 bonds. But if you go back to the periodic table, it is in the second row, which means that it can make more than 4 bonds if it wants to. So what we're going to do is take each oxygen is going to give up a lone pair. And each oxygen is going to help share a bond with sulfur. So each one of these lone pairs is going to help share with oxygen. So this lone pair is going to make another bond, this lone pair is going to make another bond, and this lone pair is going to make another bond. So we end up with a structure that looks like this. Alright, now each of those now only has 4 on the outside. And if you count up all of our electrons, you'll notice that we use all 24 in this structure as well. So let's look at formal charge now. Let's do the sulfur. Sulfur has 6 valence electrons, and it's making 6 bonds. It has no electrons on it, so we don't have to subtract those. And perfect. And oxygen has 6 valence electrons normal, and it has -4 electrons on it and -2 bonds, so it has a formal charge of 0. So this is a better Lewis structure. Thank you for listening. I hope that helps. We're going to be doing molecular geometry next if you need help with that. Thanks.